Thank you.
Hey, so and by the way, I want to be in a way slightly meta about this. So I'm going to tell you stuff, some of which you already know. But a lot of the slides I'm going to show you, I've also shown to legislators, judges, court administrators, people who do not have a technical background. And so, because part of my role in this is part of my role is to be a scientist, but part of my role also is to explain these things to people because I don't want people to be intimidated by AI. I want them to understand it as best as they can. I want them to understand its strengths and its weaknesses. And I want that understanding to be spread as broadly throughout society as possible so that we can all make good democratic decisions about when to use AI, when not to use it, how to use it, what guardrails to put around it, and so on. And so, maybe reserve part of your brain for thinking about, gee, is this a good way to explain this to a genuinely broad audience? I also know that you are a broad audience, which is awesome that this is a cross-listed course. So, I'm going to talk about pretrial risk assessment, and so for, I'll get into this in a second. So first of all, here is our little band of siblings here, including your illustrious professors Melanie Moses and Matthew Frick, and other people from other departments, including the law department at UNM, and political science, and then a smattering of people from and also Chelsea Estrada, and a smattering of people from other institutions, some of whom are connected through the Santa Fe Institute. Um, and honestly, at the moment, this is just a mailing list, but interacting with these people for me has been really important, right? So I'm actually a physicist by background, but I'm mostly a computer scientist. And so talking with people in law and political science has been really, really important in not just broadening my perspective, but making sure that my work as a computer scientist is more relevant and actually helpful and actually grounded in the debates that people are having in the real world. Um, so let's talk a little bit about bail reform and risk assessment. And by the way, I'm kind of a liberal guy. Um, I've moved somewhat, I would say, toward the center, but I'm still a little bit left of center. I want to put this out there because my initial feelings about the justice system and jail and prison and all that was the kind of standard liberal feelings like, oh, we're jailing lots of innocent people and that's terrible. I've also had lunch with prosecutors who have been like, I just came from a Mother's Day memorial service for mothers whose sons have been killed by homicide in Albuquerque, and so this has kind of broadened my view a little bit. So we can talk about that because if we want to talk about crime and AI, you have to talk a little bit about crime. But anyway, let's talk about pretrial detention. So what does pretrial detention mean? So this means that you've been arrested, but you have not yet been found guilty of any crime. You've not guilty, you have not agreed to a plea deal that says you're guilty, you haven't had a trial. Um, there are currently about between 400 and 500,000 people in the country who are in local jails run by counties and cities who are in this state. They've been arrested, but they have not yet been found guilty of any crime. Um, these people are disproportionately low income, and they're generally people whose skin is darker than mine. I want to pause here and say I'm going to do a lot of editorializing. I know some friends of mine on the left focus very much on the fact that the people in jail are disproportionately people of color. I agree that's a problem. I think it's a problem that comes from our nation's history. It also comes from correlations between one's color and one's class and income. Um, But I also just think that in this country, we have way too many people in jail in general. You may know that compared to most other civilized nations, we have many more people in jail than most other countries. We're kind of an outlier that way. And these are not the same problem, so uh, although they may have overlapping solutions. All right. Anyway, now, if you put me in jail for even just a month, I could easily lose my job, lose my apartment. I'm unable to take care of my kids. Um, but a lot of people sit in jail for over a year waiting for their trial to take place. So often this pretrial period is much longer than you might think. So if I'm in jail for a year, well, all sorts of things are going to happen to me and to anyone who depends on me. My marriage will fall apart, etc. I might lose custody of my kids. And some people argue that these effects on me make me more likely to commit crime in the future because of the fraying of my social network. On the other hand, it really is true that a small fraction of defendants who are pretrial, who are let go pretrial, go and do something terrible. And as a result, this makes a lot of people, including the victims or their families, say, well, you had this guy in jail. Why did you let him go? And if you look at the political debate, especially what the police or what prosecutors say, they complain of a revolving door, catch and release. You arrested him, but you let him go. Well, the complicated thing is that in our society, we have this you're innocent until proven guilty idea, which, by the way, not every nation has. And so, strictly speaking, if I haven't yet been found guilty, why should I be incarcerated, right? Why shouldn't I be allowed to go about my life? And so this is a tricky constitutional and philosophical issue in the United States. So who, if anyone, should be detained, even in the absence of a court finding that they were guilty of something? So along the same lines, we all watch TV probably, so you know that in a lot of states, in most states, in fact, and we got this from the English, when you're arrested, the judge says, "Well, I'll let you go if you put up a bail bond of like $10,000." And then a bail bondsman says, "Oh, well, if you give me $1,000, I will put up that bail bond of $10,000." And there's $1 billion industry around this. On the other hand, this seems like a sort of weird way to do things, I would argue. I mean, it seems like a kind of bizarre bank shot to say, well, we're going to use how much money we're going to ask you to put up as a bond as a kind of proxy or a mechanism for determining how dangerous you are and whether or not you should be in jail. Um, and it seems as if, roughly speaking, this is saying if you have the money, you get out, whether or not you're dangerous. And if you don't have the money, you stay in, whether or not you're dangerous. And in fact, of those hundreds of thousands of people currently in local jails, many of them are in jail because they cannot afford a bail bond of only, say, $1,000. Um, and so partly, I think so. A number of states are moving away from this kind of cash bail or financial bail system. Illinois, California, New Jersey, Kentucky, but New Mexico was actually one of the first. So in 2014, there was a case where a young man, um, he was a teenager, he was at a party, there was a fight, he had a knife, and he killed someone by his own admission. He had a perfect record. He felt terrible, or certainly said he did. People believed he felt terrible. And he had a relative to live with. He had a job that his employer was going to say he was going to keep. And even the prosecutors basically said, yeah, this was kind of a one-time thing. There should be consequences, but there's no evidence that he's going to go out and do this again to anyone else. Um, Nevertheless, he was held in jail because he couldn't afford a $250,000 bail. So the New Mexico State Supreme Court said this is unconstitutional. You can't hold him in jail just because he can't afford that bond. So then in 2016, the New Mexico voters voted to amend the Constitution to say the following things. A person who is not really dangerous or a flight risk, meaning they're going to try to avoid the system, may not be detained simply because they cannot afford a money or property bond. On the other hand, a judge may deny bail to anyone if the prosecutor makes a good argument to them, clear and convincing evidence, that releasing them would be really dangerous. And even with conditions of release like supervision and so on. Um, so this was a fascinating constitutional amendment. It basically said we're not going to use cash to hold people in jail. On the other hand, if prosecutors convince a judge, then anybody, particularly any felony defendant, can be held in jail without bond. But the idea here is to move towards an assessment by a judge of dangerousness. But how should we make these assessments? So, well, historically, historically the United States justice system has all kinds of bias in it. I don't think this is controversial. I don't think it's just liberal people who would argue that. And it's not just Jim Crow judges in the American South. Um, so one idea was, well, let's use AI. Try to give judges some objective advice about whether somebody is dangerous based on various things about them. Now, in around the same time, ProPublica, which is a kind of data journalist outfit, produced this article claiming that a particular uh, software package called Compass was racially biased. I have to tell you, this article turns out to be wrong in many ways, and we can go into that if you want. And in the end, I do think that bias is a potential issue in these systems. I do think we should be alert to that possibility. We can go a little bit back and forth about what ProPublica said and what the kind of rejoinder was from other statisticians. Um, but in the end, I don't think this was the fundamental issue about Compass. I think the fundamental issue is not that it's biased, it's that it's opaque. It's that people do not know how their risk score is calculated. And Compass is also used in particular for parole. And there was a guy in New Jersey who had served a long sentence, again, for a murder done when he was a young man that he acknowledged he did. He had an exemplary record. He was up for parole like 16 years later. And the parole board had incorrectly typed into Compass that he had had many disciplinary infractions as an inmate, whereas in fact he had had very, very few and none in like the past dozen years. Because Compass is opaque, because it's a black box, in fact, he doesn't even have what computer scientists call black box access to it. He was not even able to tell the parole board what his score would have been if the correct information had been given to Compass. And because given the incorrect information, he was labeled high risk, and given the political fallout to the parole board and to the governor who appoints the parole board of letting somebody out who is labeled high risk, they said, we're not going to parole you. And 2 years later, he came back, and they actually overrode its recommendations. So I do think that bias is an issue, but opacity is another issue. And I know that Matthew gave you the communications in the ACM piece. I encourage you to read that. It was written by a bunch of people, including me, arguing that when constitutional issues are important, transparency in AI is really important. You shouldn't be told that you should be held in jail without a very clear explanation of why. And we can get into that. Like people in AI talk about explainability, they talk about interpretability. I think transparency is actually a different and stronger notion, although we can talk about what it means, So I would love to have that debate with you. Anyway, so I think transparency is important. I think we should know what data does an algorithm use about a defendant, or for that matter, about a job applicant, to make a decision about them? What does it do with these facts? How does it weight and combine them? You might say, oh, well, neural networks are really hard to understand. So, you know, How can they be transparent? Yes, that's true, although people are working on that. Um, the fact is that a lot of things that are out there now affecting people's lives, including Compass, are not deep neural networks. They're very simple regressions, logistic regressions, or linear regressions. They are actually very easy to understand. Um, so don't fall for the argument that I've heard the industry make that says, well, these things are very hard to understand. Even those of us who make them don't really understand them. So don't ask us for transparency. That's a bad argument. There are both legitimate and less legitimate gaps in our understanding of these systems. Yes, if you have a really deep neural network with a lot of layers and a lot of nodes, figuring out why it gives the output it does in a way that machines can understand is tricky. That is a real gap in understanding, and good people are trying to close that gap, both in academia and in industry. But if the company says, oh, this is a proprietary product, it's a trade secret, you may not look inside it, we're not going to tell you the weights, well, I would argue that is a very different kind, and in my opinion, a less legitimate kind of gap in our understanding. So, all right. And by the way, where does the data come from? How is it collected? How is it coded? And this is the concern from people who argue against the use of these systems in the justice system. Does it contain or reproduce various kinds of historical biases? That's important too. Um, by the way, uh, in this particular domain of pretrial detention, the information that current systems use comes from your criminal record. Um, so On the other hand, you can imagine a future system that uses surveillance from your town and your behavior in your town and where you go and what you do. So that's not going to be so relevant to what we're talking about today. But in a lot of areas, you might want to know how is this data collected? And you might, if you are kind of a libertarian or someone who's concerned about surveillance of people by the government or by corporations, you might have concerns and you might say, hey, this data should not be being collected in this way, even if it would help solve a problem. Okay. There are some other gaps in people's understanding. Do the people affected by an algorithm and the decision makers advised by it, such as a judge, do they understand what its outputs mean? Do they understand its strengths and weaknesses, including what kinds of errors it can make? As we'll talk about later, if I give you a verbal label like high risk, do they understand what this actually means in terms of probability? Yeah, how much risk and risk of that of what does that actually mean? So these are additional gaps, I would say, in people's understanding. In this case, understanding of what does the output mean and how should I, as a human decision maker, take that into account. By the way, some of this is in another reading that I sent Matthew, which I'm sure you haven't had time to look at. It's from an MIT series on social and ethically responsible computing, which is written for computer science undergrads. And if you have time, I would urge you to look at that as well. Okay, anyway, um, let's talk about a couple of things. Okay, let's talk about false positives and false negatives. Okay, this is Judge William Blackstone, a very famous English jurist and philosopher. He was very concerned about what we will call false positives, where we put someone in jail even though they're not dangerous or not guilty. And he says it is better that 10 guilty persons escape than that one innocent suffer. So basically, he's really concerned about a government imprisoning an innocent person. And he thinks that's such a bad thing that he would rather have a lot of guilty people go free. Here is another philosopher, our former vice president, who, in speaking about Guantanamo Bay, said, I'm much more concerned about bad guys who get out than the fact that we detained a few innocent people. Now, I've obviously put up a picture of him partly because I'm making fun of him. But if he were here with us today, he would say, look, I was trying to prevent additional 9/11 style terrorist attacks. And So the threat of letting a guy out who is going to plan another attack that will kill thousands of people is so dangerous that yeah, I'm willing to detain a few innocent people to avoid that attack. So he's concerned about false negatives. Um, so one thing that we forget sometimes in machine learning is that the cost of a false positive versus the cost of a false negative might be very, very different, whether this is true in health or in justice or in lots of domains. And so rather than just asking what's your error rate, you need to ask, well, what's the cost of your errors? And figuring out how, like, quite literally, how many false positives is equivalent to a single false negative, right? Quite literally, let's say that you are a New Mexico state legislator and you are considering a policy which will hold in jail for a year 10 people who would not be dangerous if you released them pre-trial for every felony arrest that you prevent. Okay. Is that a good ratio? I don't know. Would you run screaming out of the room if I said, what is the ratio? Give me a number. I don't know. These are hard questions. I think most of us as human beings don't even want to think about these questions quantitatively. One great legal scholar, Lawrence Tribe, says there is no exchange rate. There is no numerical, there's this term fungibility or exchangeability between the rights of the defendant and the needs of society. The defendant is an end in themselves. Sounds like Immanuel Kant if you're a philosopher, and you just cannot trade away their rights for the safety of society. Well, okay. On the other hand, if you're designing a risk assessment algorithm, you're going to have to face these issues and figure out how it should be optimized. All right, I better get moving, but the philosophy is interesting. So let's go meta a little bit. Maybe you already know this. Let's suppose I have a whole bunch of defendants and I'm trying to separate the green ones from the red ones. These are not races, they're behaviors that I'm attempting to predict. The green ones are the ones that if you let them go, they will not commit any new crimes, and they will show up to court. The red ones are the ones who will commit some new crime. Um, I am going to line them up in order of some number which my algorithm is producing, my risk assessment score. If that score were perfect, it would divide them like this, and then I could put a threshold there, and then I could tell a judge detain everybody above this threshold and release everyone below the threshold, and that would be great. Instead, the situation looks much more like this. And then these people are false positives who I would detain unnecessarily because they're above that threshold. These people, I could reduce the number of false positives by raising the threshold, of course, but now I have more false negatives, people who I've let go under that new higher threshold, but they're actually dangerous, and I maybe should have detained them. Of course, I could lower the threshold, but you see the point.
Chris, we have a question.
Yeah,
Yeah, I don't have a good sense of what the like base rate is for high risk in this situation, right? And that seems like
very good.
equally important here.
Very good. We will get to that. We will get to that because um, the fact is that even at the high end here, there are more greens than reds. So, now if you know about the receiver operator curve, you know about this thing where you plot some people call it the sensitivity and specificity, some people call it the false positive versus true negative rate, blah, blah, blah. I always get those mixed up. I always have to look at the Wikipedia page every time I think about it. Um, And, so you know that there is a way of assigning an overall score to a risk, uh, an overall accuracy to a risk score, a ranking, where you vary the threshold and look at the false positive versus false negative rate. I'm not going to show you that thing called the receiver operator curve, although it's certainly something you should know about, because these are slides I show to non-technical people. I'll just mention there's this thing called the AUC. How many of you already know what that means?
Just
Okay.
one.
All right, Matthew, you need to teach them about the AUC.
Yes.
It is the area under this thing, this curve that I'm not going to show you, but it has a nice equivalent definition, which is if you were to choose randomly from all the red people, the quote risky people, and randomly from all the green people, the AUC is the probability that you would correctly rank that random red person as more risky than that random green person. If all the reds were up here and all the greens were down there, this probability would be 100%. But if they're mixed, then okay, here's another pair that we get right, but here's a pair that we get wrong. Okay. So to the extent to which you have some risky people actually ranked as less risky than some more risky people, and conversely, that lowers the AUC. If you had something totally random, the AUC would be a half, and that would be like flipping a coin. That would be like no better than chance. All right. Now, so in this case, if it were two-thirds, the AUC would be 66.7%. And then we would take this thing and lump it into low and high scores and so on and tell people, oh, well, they got a 7 out of 9 on this, 7 out of 10 or whatever. All right. So in medical diagnostic studies, an AUC of zero point 0.9 is considered good, zero point 0.8 is considered acceptable. Crime is difficult to predict. Crime is a very noisy thing. Even if somebody has the propensity, and of course, criminologists argue about this, philosophers argue about this. I mean, even if you have the desire to do a crime, you still need the opportunity and so on. So crime is quite random. Also, often you don't really have the desire to do a crime, like apparently that kid with the knife at the party, but you get into a bad situation and something bad happens. So crime is difficult to predict. Typical AUC is like zero point 0.6 something, or in the low 0.7s if we're lucky. And this is humbling, right? This is humbling because it says that this is not like in the movie or the book Minority Report, nor it is like the TV show Person of Interest, if you've seen that, which I really like. We just do not have the ability to say, oh, this person is 97% likely to commit a crime. We just can't do that. Um, so more than one-third of the time, we're going to get people in the wrong order about who is risky and who is not. And incidentally, humans working intuitively do about this well as well. To be fair, though, as I'll show you, the rates of new criminal activity, which is what I'm going to show you next, do seem to be correlated with some of these risk scores. So anyway, let's go there. All right. I want to mention one other thing about accuracy, since this is a broader subject. There is a predictive policing product out there called PredPol. It's now a company called Geolytica. I actually know some of the people who worked on it. They're not bad. They're good people. PredPol does not it does not look at individuals. It looks at places and times. And it does something that human criminologists have been doing for decades, which is try to identify so-called hotspots, places and times where crime is more likely to occur, and to look at that based on the time of day, the day of the week, and so on. This is a perfectly reasonable thing to do. I think everybody recognizes that there are such hotspots. PredPol does this using a little statistical model, which is kind of related to models for earthquakes, and you know, it's not a bad thing to try to do. And then the idea is that you would send patrol officers to that place. So, but they charge money for this and they license it. And on their marketing materials, they say it is twice as accurate as human analysts. Okay. 99.9% of reporters will just say twice as accurate. Very few people have the savvy that you have, because what you are thinking right now is, wait a second, what number is twice as big as what other number? What thing is being divided by what other thing? What's the numerator? What's the denominator to get you something which is twice as good? Let me tell you. So they did do a peer-reviewed study. And in the yellow boxes, you see here what's going on. ETAS is the statistical model that they were using. It's excitable something something. Um, Look at the top line. In a particular neighborhood of Los Angeles, 6.4% of the crime occurred in the times and places that PredPol, the algorithm, thought it would. 3.2% of the crime occurred in the times and places that the human analyst thought. And 6.4 is twice as big as 3.2. Okay? If what they said was, well, about 94% of the crime doesn't occur where the algorithm thought, and 97% of the crime doesn't occur where the human thought, well, that wouldn't sound nearly as good, would it? I bring this up because you are our ambassadors going out into the world, and it may fall to you to explain to a reporter, to a policymaker, to a chief of police, to a judge, to somebody who is not quantitatively minded, to say, hey, when they tell you it's twice as good, just can you please dig in a little deeper and find out what, what thing is twice as big as what other thing? I mean, after all, we're always being told if you eat potato chips, it doubles your chance of a particular kind of cancer, when that kind of cancer happens very, very rarely anyway. So it goes from 1 in 10,000 to 2 in 10,000. And so that's called relative risk. That's important. Absolute risk is also important. I'm not saying you should eat potato chips, but this is the kind of literacy or numeracy that many people in our society don't have. And so as a result, it is easy for the vendors of AI systems to overstate and overimpress people with the quality of their products. All right, moving on. Okay, so I got involved with a quote audit or evaluation of not Compass, but a different risk assessment that I think Matthew has also told you about called the PSA for the Public Safety Assessment. Um, that's what that stands for. I just want to tell you how I got involved because I've met a lot of computer scientists who are like, hey, Chris, it's really cool you're doing all this stuff with legislators, but I would have no idea how to do that. And, I got involved by calling my legislator. Um, by the way, we live in a small state. There are fewer people in New Mexico than there are in Brooklyn. It's a big state, but the population is small. Each legislator, each state senator, and each state representative represents a small number of people. If you ask to have coffee with them, there's a good chance they will say yes. So, to be fair, I had been involved in politics a bit, so I knew people who knew people. So I wasn't starting totally cold, but try it. Try it. So I called my state senator, Peter Worth, who also happens to be the majority speaker of the state house. He's part of the Santa Fe Democratic establishment. He had coffee with me. And I said, hey, I just read this ProPublica article. This was like 2016. And I think that the state legislature should pass a law saying that we will not use any opaque systems to make important decisions about people, certainly not in the criminal justice system, that we demand transparency and independent studies, independent audits of any system being used. And he said, that's interesting. Let me introduce you to my friend, Charlie Daniels, who is the former state Supreme Court justice who played a very big role in the bail reform effort and who had helped introduce this. So this is the public safety assessment. Have you already seen this little figure, this matrix? Yeah, okay. I can't really see you on the screen anyway.
They've seen a summary slide with these things listed, but not
Okay, good.
this detail.
All right. So what is this? So this is a risk assessment. It is a competitor to Compass, and it's a successful competitor. It is now used in far more jurisdictions than Compass is. Was this invented by evil people who want robots to put us in jail? No. It was invented by a criminal justice reform-minded foundation called the Arnold Foundation, now called Arnold Ventures. And it was based on a big study, and they basically wanted to give judges as objective information as they could But it is also completely transparent. The whole algorithm is right there on the screen. You get a certain number of points for each prior conviction, for each failure to appear pretrial in the past. You get more points for a prior felony conviction or a prior conviction for a violent offense than for a prior misdemeanor. By the way, a misdemeanor is a less severe crime, whereas felonies are the more severe ones. If you watched Better Call Saul, they kept saying petty with a prior or petty misdemeanor is like the lowest. It's like trespassing or something. It's like, when you're not trying to do anything bad, it's the lowest level of crime. Anyway, you do get points for being young. Um, and that's interesting philosophically. It turns out that a lot of kinds of crime are done mostly by young people. I mean, I was an idiot when I was a young person, no offense. People age out of a lot of forms of crime. So being young, and especially being a young man, is a very predictive factor. Now, do I think that that means we should put all the young men in jail? Or on an agricultural work camp until they're 25? Or uh, no, although it would probably reduce a lot of crime, a lot of kinds of crime. But you know, this is a philosophical question. I don't think, you know, I mean, you could argue that this is discriminatory, but it's so strongly predictive that it is hard to give up if you're trying to build a predictive system. On the other hand, there's some other things it does here. It does not use it does not use past arrests. It only uses past convictions. Now, this is interesting because the police and the DA, that stands for district attorney, that's the prosecutor who's trying to argue that someone is guilty, they often say, yeah, we've never convicted this guy, but we've arrested him a bunch of times and we know he's a bad guy. And the fact is that prior arrests in and of themselves turn out in this, when people have done studies, not to be very predictive of bad behavior. And, homeless people get arrested a lot, et cetera. On the other hand, there was a real case involving a defendant named Darian Bashir in Albuquerque. You may have heard of this. This was a couple of years ago, where the DA said, hey, we arrested this guy before. He shot at somebody from his car. We were unable to get a conviction. We claim that that's because this guy intimidated a witness, so we couldn't get the witness to testify. Right. So they say, look, yeah, it's true. He has no convictions on his record, but come on, Your Honor. It's insane for the PSA to give him a low risk score because of that, because the only reason he had no convictions was that he's a really bad person who intimidates witnesses. This could be true, right? It's entirely possible that this is true. And I think the right thing to say is, if you are building a statistical or algorithmic tool to predict the behavior of people based on their criminal record, you should not use arrests, whereas you should use convictions because they are more predictive. On the other hand, judges should understand that the best this tool could possibly do, even if it were the most scientific thing in the world, would be to predict the average behavior, the average rate of new crime on the part of people with a similar number of convictions in the past. It does not know that the defendant intimidated witnesses. It also does not know that the defendant has 3 prior convictions, but now they've turned their life around and they're in culinary school and they're a regular churchgoer and they take care of their kid's sister. It doesn't know either of these things, and that is by design. It only knows what you see there on the screen. So, by all means, the prosecution and the defense should argue to the judge what it is that makes this defendant more dangerous or less dangerous than the average defendant with a similar criminal record with similar input factors to this algorithm. And the judge should listen to that. So you might say, well, what good is this then? Well, it is good at predicting the average behavior of people, and it used to be that the DA would say, hey, judge, you have to detain this person because they are charged with X. And everyone knows that people who are charged with X, Y, or Z are dangerous just because they were arrested for that. This turns out not to be true. And things like the PSA can remind judges that actually, even people who are charged with X, Y, or Z are often relatively low risk as pretrial defendants. So, yeah, anyway, by the way, it also does not use your juvenile record. This is an interesting choice. If you've done a bunch of horrible things when you were 15, 16, or 17, this might indeed be predictive of doing horrible things once you are an adult. Um, they don't use this, and I think this is some combination of they wanted to be used statewide, and some states who have access to the juvenile record, some states who don't. Um, and maybe it was also a philosophical choice on the part of the people building this system that fundamentally they recognize that a lot of people do crazy things when they're a teenager, and they wanted to give you a fresh start. They wanted to give you a blank slate when you reach your majority and become an adult. This is profound because it could easily be that lots of things, including, by the way, where you live and whether you were raised by one parent or two, and whether you completed high school, lots of things like that could be predictive. They could be correlated with your behavior. And yet, for philosophical reasons, we might want to not use those variables, even if they would make the system more accurate. We might not want to use them because we want to give young people a break, or because we don't want it to say, hey, all the brown people who are from this zip code are more dangerous than all the white people who live over here, right? Even if statistically that were true.
So
And I'm
Chris,
not
I
saying
have a
it
quick
is,
question.
but
So I was
even if it
asked,
were,
Chris, I was asked this question when I talked about these the scoring system last class, and I didn't have a good answer. I think you're addressing it, but I want to ask directly.
thank you for being my first interruption. You get a gold star.
All right. Okay. So how were these particular metrics or scoring system, how were they chosen? Was it just sort of common sense discussions? Was it, I mean, you're talking about excluding some things that may be predictive.
Good.
Who made these decisions and how?
Um, Several answers to your question. One is there are many levels of transparency that we might ask for. In a sense, like in terms of like open source code, the algorithm is in front of you. So as an artifact, as an algorithm, it's transparent. You're asking, but why is this the algorithm? Can I see the training data? Can I see the way the learning algorithm that was used to select these features and not other features? For instance, to select convictions and not arrests. Can I see how you came up with these integer scores? Why should this be 2 points and that should be 3 points? Um, this is a deep this algorithm is not transparent in those ways, and that's important to know. The training data is not entirely accessible. Parts of it are, but parts of it where it was data from lots of jurisdictions around the country, and they had different agreements with them, and there are some privacy issues. So the Arnold people cannot share the training data with us. From the grapevine, we kind of know what this was. It was like a linear regression or a logistic regression with then some feature selection that basically said if a feature is strongly correlated with a new arrest during the pretrial period, then, and it's not very strongly correlated with other features, so it's relatively independent, then maybe we should use it. And then there was a bunch of additional massaging to make it easy for jurisdictions to use. So they rounded coefficients up or down to the nearest integer because they wanted it to be totally transparent and they didn't want people to have to add 6.17 points. Um, so there was a combination of things that went into it. Um, right. By the way, I mean, if you're concerned with the historical bias in the justice system, you will say, okay, look, people of color and low-income people have historically been over-incarcerated in the past, And so, even if it is currently, we're not using race here at all, but I mean, to some extent, if there's an unfair correlation with past convictions and your race or your income, then using past convictions is going to perpetuate that. And the answer to this claim is yes, that's possible. That is possible. The hope among the people who designed it is that past convictions are, for instance, somewhat less racially biased than past arrests, because with convictions, there's a little bit more of a process to go through. Um, yeah, anyway, but these are deep questions, and the designers of the system are not necessarily, like adopting the greatest system in the world is not necessarily going to undo historical bias in the training data that went into making the system, if you see my point. So I hope you're getting the sense this is a many-leveled question, and that's okay. I better hurry up here a little bit. So what do we do with these scores? So actually, the PSA produces not one, but two, and in some sense, three different scores, rather than a single score saying this person is a risky person, this person is a less risky person. It produces two different things. One is NCA. This stands for New Criminal Activity. Really important point here. This doesn't mean you committed a new crime during your pretrial period. It means you were arrested. Huge, obvious, but huge point. People are arrested for things they didn't do, and people do a lot of things they don't get arrested for. About half the crime does not lead to an arrest, according to FBI statistics. And it's worse than that, especially for like child abuse and domestic partner abuse. So, this proxy variable of arrest for crime is imperfect in both directions. Um, and as a side note, a lot of people think that if we're talking about domestic violence, we need to build a kind of separate tool and a separate pipeline to address the risk of domestic violence for multiple reasons. One is that sending a defendant back home is a little different in domestic violence than it is for other kinds of crime, right? So anyway, so it tries to predict new criminal activity, which means rearrest. It also tries to predict failure to appear, which means you're going to miss one or more of your court hearings. More about that later. So it gives this pair of scores, and then each jurisdiction which adopts the PSA adopts something they call the release conditions matrix, sometimes called with some more bells and whistles, the decision-making framework. And this is what we recommend to judges that they do with people who have, say, a failure to appear score of 3 and a new criminal activity score of 5, which you look up that row in that column and it puts them in this orange box marked with a K. And that says release on own recognizance, ROR, so they are released, but with pretrial management level 4, which might mean you have to wear an ankle bracelet, which lets us track you with a GPS. It might mean that you have to check in every week with a parole officer or a supervision officer. It might mean mandatory drug tests. Okay. A really important thing about this matrix is this is not science. This is science. It's not easy science, it's tricky science, it's science that you can argue about, but it is at least an attempt to build a statistical system to predict rearrest or failure to appear from factors in your criminal record using quantitative methods. What we should do with you, based on your risk level, is a matter of policy and is some confusing combination of what will succeed in in lessening the probability that you will commit a new crime and also ensuring that you show up to court. And it is muddied up with what you deserve. In criminology, there are a lot of different philosophical things about this. And in Bernalillo County up through 2023, at the high level here, Bernalillo County is basically Albuquerque. If you had high scores on these things, then the recommendation to the judge was to detain you, or because of the New Mexico Constitution, either to detain you or to release you with the maximum conditions something like that. Um, anyway, so this is another profound point. Estimating your risk level is one thing. Telling a judge or a policymaker what should be done with you at a certain risk level is another thing entirely, and is largely policy driven and philosophy driven. All right. So we were given a bunch of data on 15,000 felony defendants over a 4-year period that were released pre-trial. Another profound issue. We only get to know whether you will commit another crime if we release you, just as a bank will only know if you return a loan if they give you the loan, and a university will only know if you will do well at college if they accept you to college. So this is a fundamentally one-sided problem in data science, and that's profound and important. So we know lots of things about these people, the charge that was filed against them, their past convictions, past failures to appear, all the things that go into the PSA. We know whether the prosecutor brought a motion saying to the judge, hey, judge, I think this person is really dangerous and you should detain them. And we know whether the judge agreed with the prosecutor if they did. We also know if they were released, whether they were rearrested for anything, and if so, for what. Was it violent? Was it non-violent? And VCA is new violent criminal activity, being arrested for a violent charge pre-trial. And we know where they showed up. Okay. Then you do a bunch of bar charts. And here is the FTA score. The PSA returns a score on a 6-point scale, 1 through 6. And it does look as if the fraction of released defendants who failed to attend at least one of their court hearings goes up pretty well with this score. It looks well correlated. Okay. By the way, I had to argue with my co-authors about including error bars. You have to include error bars or you're living in sin. But a lot of people in this job, and even in machine learning, don't include error bars. All right. Here's new criminal activity, the rate at which somebody was rearrested, scored and its correlation with the new criminal activity score. Again, it looks pretty well correlated, even though, remember, the AUC wasn't very large, but it looks pretty well correlated. It seems to top out around 30% in Albuquerque. So yeah, at the high level, 30% of the released defendants were rearrested for something during their pretrial. And that sounds really bad. It kind of flattens out a little bit at the top. Maybe that's because the really dangerous people, the prosecutor is convincing the judge to detain them. We don't know. That's speculation. All right. Okay. Then we were asked, okay, can we tell whether this is unfair to different racial and ethnic groups? Couple interesting things here. One is ours was the first study to include Hispanic and Native American subpopulations, as well as Black and white. Little asterisk here. In the computer science world, when we measure the racial bias of an algorithm, we make an assumption which is hard to avoid, but pretty horrible, which is that everybody belongs to one group, right? You know, we all know that race is kind of bullshit anyway, and that it's not really well defined. We know that there are Hispanic people, and for that matter, African American people and Native American people of all sorts of different colors. We know that how you identify yourself is different from how various actors in society view you. So I am really troubled by the fact that usually what we do is we divide the population up into these very neat subgroups and then measure whatever in each subgroup. Because I personally think that part of the problem with our society is that we divide people up into those groups. I'm not sure how to do it any better, but I'm troubled by it, and I think you should be too. Another interesting fact about the United States, you may be aware that the whole notion of race is quite different in this country than it is in many, many other countries. And that at the national level, we focus a lot on the binary, the one bit of black versus white. In fact, if you read studies on this, they often say we look at whites versus everybody else, or we look at blacks versus everybody who isn't black. Here, New Mexico has a uniquely diverse demographic, so we had significant subpopulations across these four groups. Anyway, what you see here is the new criminal activity conditioned on what the PSA score says, broken out into these four groups. What would be a sign of racial bias? Okay. Suppose that the Hispanic fives were much less dangerous than the white fives. This would mean that the PSA was biased against Hispanics because by lumping them in with the more dangerous white fives, it would be implicitly overestimating how risky the Hispanic fives are. And if it did that across many categories, it would indicate that there's something about the PSA which is systematically thinking that Hispanics are riskier than they really are, and or thinking that white people are less risky than they really are. So if you saw one bar consistently being below another bar, that would be a sign of possible racial bias. It's
Chris,
there are
sorry to interrupt you. I'm curious. You mentioned those are error bars. Are they standard error? Or are they something else? Does overlap indicate not statistically significant?
aha, haha, oh, how long do we have? These are standard error bars, and of course, once you start dividing people into subpopulations, the ends are smaller, so the error bars get bigger. If two error bars overlap, does that mean there is no? Okay. Oh my gosh. Let's look at the. Sorry, you're under. This is underneath the Zoom window that shows me all your faces. All right. Okay. Let's look at I'm going to briefly okay. We have Native American. The Native American group seems to be below the African American group in every category except the category who got a risk score of 4. However, in most of those groups, the uh, error bars overlap. What the heck does this mean? Well, have you heard of the Bonferroni correction? Have you heard of? Okay, I actually kind of don't want to spend too much time on this, but there's this notion of statistical significance, which is kind of BS. There's this thing called the p-value, which says, oh, well, if this thing would happen by chance under a null hypothesis where these two groups are the same, with probability less than 5%, if the probability of getting this data, if there were a difference between the groups, is less than 5%, then we should say there is a statistically significant difference between the groups. On the other hand, even if you believe that's a good threshold when asking single questions, we are asking something like 6 times 12 different questions here. And as a wonderful XKCD, look it up, XKCD statistical significance will tell you, if you ask 20 questions, one of them, if you use a threshold of 5%, because that's 1/20th, one of them will appear to be statistically significant, even if there is no pattern in the data at all. Okay. So I would argue that there is because there is this kind of systematic difference between the Native American group and the other groups, I would argue that we should be vigilant as more data is collected for possible bias against Native Americans. But I would not say that there is unequivocal evidence that it is biased. Okay? I would also say this is only one aspect of algorithmic bias. This aspect is called calibration. So there is evidence in some states that black motorists get pulled over and have their cars searched than white motorists. Now that in itself is not necessarily evidence of bias if it were true that on average black motorists were more likely to be carrying contraband in their cars, that, guns, drugs, whatever. As a matter of fact, though, in those same states, it turns out that conditioned on being searched, the black people are less likely to have contraband in their cars than the white people are. Now that is evidence of bias. That suggests that the police are implicitly at some level using a lower risk threshold for the black motorists than for the white motorists. Okay, still with me? So similarly, if the rearrest rates were systematically lower at each risk level for one group, it would suggest that maybe we're biased against that group. This is true for women. So for rearrest, women do less crime. Sorry, just have to say it. Now, and yes, each individual thing overlaps, but when you combine all of these together and do a little more fancy statistics, it is quite unlikely that there would be this systematic decrease from men to women in every category unless there really were some bias against women. What should you do? Well, you could give men an extra risk point or women a -1 risk point. Or you could just tell judges this and say, Judge, we decided not to use gender as an input, but you should be aware of this difference and take it into account. All right. There are lots of other notions of fairness other than calibration. In particular, if you believe that different racial groups should not have the same, should not have different false positive rates, which is what ProPublica used in that article about Compass. They were concerned about false positive rates. Passing the calibration test does not mean you will pass the equal false positive rate test. Nor does it mean you pass the test of possible historical bias, where there are things going into the algorithm which are correlated with your race or your class, and they're also correlated with whether or not you get arrested. So maybe they are correctly predicting that you'll be rearrested, but in a circular manner, which is unfair to you. And it is important, as these people Eckhouse et al. Say, arrest is not just a fact about your behavior. It is a complicated combination of your behavior and the behavior of the police. And so it is fundamentally predicting something about you and about the police. And if the police are biased, that will feed into that. So, there's a lot of subtlety here about what does it mean for an algorithm to be fair. And I will just warn you that this debate immediately gets you up into very classic and old debates about, for instance, affirmative action. And should we use different thresholds on different groups in order to correct historical bias? Or is that in itself a biased thing to do? And we should just try to use the same threshold for everybody and try to attack the problem in other areas, like making sure that everybody has the same early childhood opportunities for a good education, make sure that everybody has equally safe neighborhoods, and so on, rather than trying to correct for those inequities with changing the thresholds later on. I mean, these are deep, deep issues that you see showing up in the Supreme Court, in debates around college admission, in debates around amendments, in debates on employment and everywhere else. So you can't get into these debates without getting, really diving into the philosophy, which is fun or terrifying depending on your outlook. All right. I have 5 minutes left. I'm going to say two things really quickly. One is, as a data scientist or a computer scientist, one thing you should do is ask, gee, thanks for the zeros and ones, guys. Thanks for telling me who was arrested and who wasn't arrested. Thanks for telling me who missed one or more hearings and who didn't miss any hearings. But can we do better? Can we look more closely at this data? So, for instance, what does this mean? Somebody's high risk. What risk and risk of what? I'm going to skip this, but first of all, the actual risk of rearrest differs wildly from one jurisdiction to another. could be for lots of reasons. But the other is lots of legislators and judges and lawyers have said, okay, maybe somebody's going to be rearrested, but is that rearrest for trespass or for attempted homicide? What are we talking about here? We should consider the nature and seriousness of the danger to the public. So can we go beyond this one bit description? Well, of course we can. And the data we had lets us do this. So this is the same bar chart I showed you before, but now broken out by the severity of the thing you were rearrested for. So again, a misdemeanor is a relatively minor crime. A petty misdemeanor is the most minor crime. First degree felony is the worst. Second, third, fourth are less and less severe felonies. So let's disaggregate, as a social scientist would say, this data. So it turns out that a very, very small fraction of those rearrests are for high level felonies. The blue here, the first degree felonies, are basically a pixel at the bottom buried in the x-axis. Then there's a couple percent which are green, a couple percent which are third degree. The fourth degree felonies are the largest category. Basically, if I punch you in a bar, that's a misdemeanor. If I keep kicking you once you're down, that's a fourth degree felony. If I show signs of really trying to kill you, then it goes up from there. So fourth degree felonies, yes, are the biggest. Fully a third of these rearrests are for misdemeanors or petty misdemeanors. Now, punching you in a bar is not a good thing to do. If there's a high likelihood that I'm going to go out and punch somebody in a bar, that might be a good reason to detain me. I'm not saying that these less severe kinds of risk shouldn't count. I'm just saying everybody should know, judges and policymakers should know that high risk does not typically mean high risk of an attempted homicide. And by the way, this pattern holds roughly even for people who are charged with high-level felonies. The standard picture is if you are charged with X and I let you out, you are going to go do X again. The same kind of thing that you were charged for. There are types of crime, like domestic abuse, where this is true. But for most types of crime, this is not true. Similarly, let's look at failure to appear. Again, this is one bit in our data. Did you miss one or more hearings? Or, but can we dig into that? Did you miss one hearing and then you got yelled at and told, look, you really need to show up for this stuff or you're going to be thrown in jail, and then you showed up? That's different from, oh, I tried to cross the state border, hop on a train to Texas, like in the movies, to escape the justice system. So failure to appear is not the same as absconding or willful flight, at least not all the time. This is something we're currently working on, but one thing we learned is that most failures to appear, people only missed one hearing. So dig deeper into the data. As data scientists, I think we often stay in our lane. We're like, oh, thank you for these numbers. I will go over and find patterns in these numbers. And if I can predict those patterns, you'll be happy. It is our moral and intellectual duty to dig in and ask, gee, where do these numbers come from? Are there more than one kind of one or more than one kind of zero? By the way, do you have richer data than you're actually giving me? Maybe we can look at that richer data. And ours was the first study in the nation, and I'm flabbergasted by this, that did this, that divided it up into what are you rearrested for? Go figure. So always look deeper. That's something you can do. Don't stay in your lane as a data scientist. Learn about the domain. If it's genetic data, learn something about genetics. If it's crime data, learn something about crime and dig in. It will make you a better data scientist and a better person. I'm out of time. There's lots of stuff I want to tell you, including, I will just say this, there are many similar debates in the world of health, where, for instance, there are proprietary systems being used in hospitals today, including at the UNM hospital, which are trying to help doctors save people's lives, and these systems are opaque, they're trade secrets, and they are in many cases not independently tested. When they are independently tested, it turns out that sometimes they don't work as well as the vendor said. And the good news is when there is enough transparency, often the independent tests make these things better. It's like, dude, you were using this variable you shouldn't be using. Retrain your system without that variable, and now it gets better. That transparency, that feedback loop where independent scientists can diagnose errors and or diagnose bias is an important feedback loop, and it makes the AI systems better. And making them all opaque black boxes cuts off that feedback loop, or at least makes it much harder to work. So I think that this theme of transparency is important in other domains as well, not just criminal justice. I think that there is a spectrum of transparency demands. I don't really care how Netflix recommends movies to me. If I watch the movie and I like it, I'm happy. If they use a black box for that, that's fine. I don't mind. Justice, if you're going to put me in jail, I deserve a totally transparent explanation. Health, interesting, somewhere in the middle. Um, some patients wouldn't mind being treated by a black box. Others would not be happy about that. I think it's really interesting to talk philosophically about how much transparency, how much insight and visibility do we need into an algorithm for it to be used in different domains. Thank you very much. I'm sorry I only got one interruption. It's quarter to
Thanks very
two,
much.
but I'm happy to talk more.
So I know that students may have other classes to go to, but if students have just 5 minutes, I'd love to hear questions. I know that you all prepared questions. Um, Anybody? Yeah, go ahead.
Oh, I guess this is more about like the presentation, but I was wondering about the ProPublica like thing. Like you said it wasn't biased, right? Or something? Was that just
Yeah, so I'll try to give a short answer. The false
Another class.
um so yeah, I'll try to give a short answer here. In a sense, it's biased. In a sense, it's not. The false positive rate was much higher among, in other words, the rate at which people were labeled high risk but then did not commit, were not rearrested for another crime, was definitely higher for African Americans in that data in Broward County, Florida. It's also true, and I think this is true in a number of counties, that the Black population was a much younger population there. So part of what happened was that Black people on average, if, in other words, it was one of these tricky situations. If you condition on age, the bias goes away. Okay. So within each age group, there was not a strong bias against Black people. But if you lump all the age groups together, then there was a strong bias against Black people because the Black population was mostly younger and young people both get higher risk scores and get arrested for crime more often. So it was one of these kind of tricky Simpsons paradox things, if you've encountered that, where it depends what you condition on. And then, so once you know that, well, honestly, like I said, the fraction of young Black men who are in jail right now is enormous, right? It's out of all proportion, I think, to what I would expect from a democratic society. It's also true that the fraction of young men in jail is pretty enormous. Not as enormous as specifically Black men, but it's pretty enormous. So philosophically, there's a really interesting article, a law review article called The Double-Edged Sword of Youth, which talks about the fact that some of the time we say, hey, you're young. We know your brain is still developing. We know you're still finding your feet in the world. We know you're drenched in hormones and testosterone, and you're trying to prove your dominance against other people in your group. Um, we know you're going through all that, so we're going to be more lenient on you. We're going to view you as less responsible for your actions. For instance, we're going to give you alternate diversion programs rather than incarcerating you. I'm a liberal guy, so that makes a lot of sense to me. There are other places in the justice system where we say, you're young, so you're more dangerous, so into jail with you. There is a big movement in the New Mexico state legislature right now saying that juvenile crime is a huge problem and we need to try more teenagers as adults. I disagree with that, but as anecdotes, or I shouldn't say anecdotes, there are real cases where people were really hurt, cases where people were hurt by somebody 16 or 17 who had a gun. Those cases exist and they make people very upset and concerned and frightened. And so it is very hard for policymakers of both parties, by the way, not to say, okay, we need to crack down on these young people. We need to treat them as adults. If they're going to commit adult crimes with adult weapons, we need to treat them as adults. So, deep questions. I personally think that a national service program where everybody spends a couple of years at around college age uh, serving in the military, or if they don't want to do that, building bridges and fixing roads and helping feed senior citizens. I am one of those people who like that old-fashioned idea. That would be better than putting them all in jail. So there you go.
All right, so we're 10 minutes past the end of class and no one has left, which either means they're just enthralled by you, Cris, or they're too embarrassed to leave. You're welcome to go. Welcome to ask more questions. Totally up to you. There's no judgment if you leave at this point. No one's okay. Right. Any other
I'm
questions?
happy to hang out.
I mean, small scale personal one, but like,
Hey, that's great.
It's just, I know one or two people who are interested in systems like this, who are working on sort of like information theoretic probability, so a lot of the stuff on your board. And just kind of interested in what opportunities there are to do stuff like this at Santa Fe.
Um, yeah, I mean, I'm happy to talk more about this. I mean, I know that you have several faculty members, including the one in the room right there, who are probably open to projects around this. I collaborate a lot with this outfit at UNM called the Institute for Social Research. It's kind of what we call a soft money outfit. They get contracts from state and county government or from the courts to do different kinds of studies. So they've been my collaborators here. Um, I've been told that getting grad students to work with them is somehow administratively tricky, but I don't understand why, and it shouldn't be. So there's probably ways to do that. You might have to, you know, get some certificate from the IRB to make sure that you can deal with data or something. Some of the data is confidential. Anyway, there's a lot going on, and I can just tell you, going back to the meta thing about how I called my legislator. I mean, I love fancy math, right? I'm a fancy math guy. I love fancy math. I love learning new fancy math. I did learn some statistics from doing this, including something called the Neyman smooth test, where you combine multiple hypotheses and the Bonferroni correction, blah, blah, blah. But mostly I didn't learn any fancy math. So doing this didn't feed that part of my brain. I love having lunch with public defenders and court administrators and pretrial supervisors and, yes, prosecutors, and judges and former judges. And, I met Charles Daniels. Sadly, he died not long after I met him, a former Supreme Court justice, who was part of the bail reform thing. I, you know, And when I've had opportunities to bring grad students and postdocs who I work with into this orbit, I've done so. And I mean, this feeds a big part of my brain and my heart because I want to understand the society I live in better. I want to make that society better. And you do not need to be an expert to help here. What legislators and judges need is simply for you to be literate, simply for you to be willing and able to understand the basics of this to them. Because they are being told by the vendors of these systems, look at this super shiny box. It's really sophisticated. I couldn't explain it to you even if I tried, and even I don't understand it, but it's really, really awesome and you should buy it and use it. You know, AI is awesome and it can do a lot of wonderful things for us, but it's vital that people like us help, quote, lay people, including judges and policymakers or whoever, understand it and treat it with, you know, both the interest and the skepticism that it deserves. Um, and it's also vital that we engage with them and learn about what their needs are. Epic is a healthcare records company that has a machine learning system that tries to predict whether you are at risk of sepsis. Sepsis is an infection of the blood. It sneaks up on you in hospital. It kills many people every year, even though hospitals watch out for it and try to treat it. Often you don't even have a fever, right? My dad got sepsis near the end of his life. So it's dangerous. And if you were a health records company who had lots of data about people's blood pressure and temperature and pulse and six other things, you'd say, hey, we can help solve this problem. Okay, and that would be good to do. Unfortunately, your marketing or legal department decided to make it an opaque proprietary system. Okay, that would probably not make you happy as an engineer or scientist working for them, but oh well, it's a big corporation and they need to make money. Um, it turns out that the first iteration of their model, because it was sort of given all the data and just did a kind of naive regression on all the data, it said, gee, people are more likely to have sepsis if they've been given broad spectrum antibiotics. Well, that's true. That's because the doctor thought they had sepsis and gave them broad spectrum antibiotics. So, yes, that's correlated. Yes, in your training data, your system should take that into account to maximize its accuracy. The only problem with that is that then out in the real world, if doctors haven't recognized sepsis yet, which is exactly what you're trying to help with, and they haven't given them broad spectrum antibiotics, then your system thinks that they're at lower risk for sepsis, which makes it less helpful. You know, so this kind of thing is happening all the time in commercial products that are being rolled out and really affecting people's lives. And often because they're opaque, it takes several years for some research hospital to decide that in the nightmare of the ER and the ICU, they're going to ask their nurses, by the way, we're doing a controlled trial here. Can you please, on top of everything else you're doing, can you please collect some data here and fill out this form, which is a heavy lift. And then they find out that this is not as useful in the real world as it was in the training day. Why? This is why. Then they make it better. And it's like, well, it shouldn't have taken that long to make it better. And it would have taken less time if Epic had just said, hey, everybody, this is how the system works. Then somebody might have said, wait, you're kind of getting the chronology wrong here. You're using the antibiotics we give people with sepsis as a predictor for sepsis. That's stupid. So anyway, I mean, I want the level of critical thinking and intellectual engagement to be higher everywhere. Um, yeah.
All right, let's stop there. Thank you so much, Cris.
All right. All right. Have a great semester. Happy to do this again.